Hey, it's Rob with Techlectic. I just wanted to show my new CNC motion platform that I've been working on. It's mostly 3D printed parts, and it's all my design. I'm using standard NEMA 17 stepper motors to do all the motion. I'm using Gerbil on an Arduino Uno to do all the motion control. In the prototype here, I'm using 3 Easy Driver stepper motor drivers to move all the axes, but I'll be switching those out to proper Allegro controllers later on once I get the main board. I've got a quick change tool system here, which just uses a dovetail to slot in tools and anchor them here so that we can change out what we want to do. And ideally what I want to be able to do with this is laser cutting and engraving. I want to be able to do vinyl cutting, light CNC milling like PCB engraving or really light aluminum engraving, and anything else I can really think of to automate with a CNC motion platform. The sky's the limit once you have a Cartesian system like this actually working. The biggest problem I'm having right now is rigidity. These 10mm rails I'm using on these LM10 UU bearings, they're just not rigid enough. I shouldn't be able to wiggle this. This won't survive any significant kind of tool pressure. And in fact, even moving on the y-axis, it actually wiggles around if I don't have the acceleration set just right. So that's where this comes in. This is my new rail system. This here is one that I've been working on. It's based on 3/4 inch aluminum square rail, which is cheaply available, and standard 608 skateboard bearings. The cool thing about this is this here is just 1/2 of a bearing unit. It's actually 2 pieces. This is just for prototyping. But the cool thing about this is it's actually like $1.50 cheaper than the pair of LM10 UUs that I'm using in these axes. So this should be a much more rigid solution. This is just going to replace the standard rails like this. I'll have to do a lot of redesigning to make it work, but I think that's going to be worth it in the end. And then once these rails are installed, I should have all the rigidity I need for a machine of this size.
Alright, so here we are back in the computer. We're in Onshape, and this is the part. So if we take a look, we can see that the chassis is designed for easy 3D printing, or relatively easy 3D printing for what it is. I'm just going to use the section plane here to take a look. We can see that there are nut holes that are cast, or not cast, but actually set into the plastic of the chassis so that everything is above the surface of the rail. That way there's no interference. On the bearing cap here, we've got a small boss to keep the bearing centered and avoid rubbing on any of these parts. Same thing inside the chassis. Here we've got M3 bolts that actually hold it to the chassis, and here a third M3 bolt is actually what adjusts the bearing up and down in the housing to clamp it onto the rail and take up any slop. And there's a total of 8 608 bearings in this assembly. We've got 2 on top, 2 on the bottom, and 4 on the sides. And 2 of those are fixed. We've got the side and the bottom fixed, and the top and the other side are adjustable. That allows for use of different size rails. The design is scalable up to 1 inch, 1.5 inch probably. But after that, you'd probably want to add multiple bearings in the stack here to take up more space and have more contact surface area. This is version 3 of the model so far. I'm about to print that and test it, and we'll see how that does.